Hello, in this video I'm going to talk about the two deployment options for Roslyn analyzers. Okay, so here I have Visual Studio open, and here is the Roslyn analyzer that I have created in the previous videos, and here is the code fix provider that I have created. And in the previous videos I demonstrated the analyzer by using the first deployment option, which is by using a VSIX project. So this is the VSIX project, and the VSIX project is a special kind of project to create a Visual Studio extension. And this project has a file called source.extension.vsix manifest, and in this file I have created two assets. The first asset is of type analyzer, and it refers to the analyzer project, which is this project here. This kind of asset will make Visual Studio look for classes that have the diagnostic analyzer attribute. The second kind of asset is called an MEF component, and this asset is not specific to Roslyn analyzers or Roslyn code fix providers. This asset can be used for any component that uses the Microsoft Extensibility Framework. And here in the code fix provider, we use the export code fix provider attribute, and I explained in a previous video that this attribute inherits from the export attribute, which is an attribute from the Microsoft Extensibility Framework. So now when I build this project, a VSIX file is generated by Visual Studio. So I can take this file and send it to another machine where Visual Studio is installed, and install this VSIX file by double-clicking on it, right? And this will cause the analyzer and the code fix to be deployed to that machine. Okay. Another thing you can do with VSIX files is publish them to the Visual Studio Marketplace. I'm not going to go into details of how to do that, but once you publish your extension to the Visual Studio Marketplace, other developers can download it from here. They also can find it in the Extensions Manager from Visual Studio by searching for it here. Okay. So one advantage of this approach is that once you install the extension in Visual Studio, any open project in Visual Studio will have access to the analyzer and the code fix provider. And one possible disadvantage of this approach is that errors emitted by the analyzer are not enforced. Let me show you. So here I'm going to go to the analyzer and change the severity of the diagnostic from warning to error. Okay, let me build. Let me now run. And once I run, a new Visual Studio instance will be opened with our VSIX installed. So here I have an error instead of a warning, right? But if I try to build, it says here rebuild all succeeded. So the error here didn't prevent building the project from succeeding. And one might consider this a disadvantage. Okay, let me show you the other deployment option. So the second approach is to deploy the analyzer as a NuGet package. And in order to create a NuGet package, I can either create a new spec file, or I can use a new feature in Visual Studio which allows me to create a NuGet package without a new spec file. Let me show you. So here I have opened the project file inside Notepad++. So this project format is a bit old, and now it's referred to as the non-SDK style project format. And if I migrate to the new project format, which is called the SDK style project format, then it would be a bit easier for me to create a NuGet package out of this project. Another thing I'm going to do here is to change the target framework from .NET Framework 4.7.2 to .NET Standard 2.0. And the reason I'm going to do that is to make the NuGet package more compatible with more types of applications. For example, if someone decided to use .NET Core and use our NuGet package, It would be better in this case if the NuGet package targets .NET Standard. So here I have pasted a pre-prepared project content, and this is the newer project format. Here it targets .NET Standard 2.0, and here it references the Microsoft.code analysis.c#.workspace's NuGet package. Okay, let me save the project. Okay, reload all. So we no longer need packages.config in this new project format. Also, the assembly info is auto-generated in this project format, so I can delete this file here. Another nice thing about this project format is that I can edit the project file from Visual Studio, like this. As you can see here, we have an element called generate package on build, which is equal to true, and this causes Visual Studio to build a NuGet package out of this project once I build, like this. Now if I go to the output folder, here is the NuGet package. Now if I take this NuGet package and reference it from some other project, the analyzer will not work because NuGet packages built for analyzers must have a specific structure. And let me show you. Okay. Here I can use syntax supported by the project format to instruct the build system to include the output file in the NuGet package in a special folder, which is analyzers/.NET/CS. And when the NuGet package is deployed to the target project, the target project will look into this folder to pick up analyzers. Okay, so now let me build this project. And let me test the NuGet package. I'm going to take this NuGet package file and paste it in this local NuGet folder. Let me now open a new project. Let's use .NET Core. Okay. Okay. And now let me add a reference to the NuGet package. Manage NuGet packages. So here I have added a new package source called local NuGet, and this allows me to test NuGet packages without publishing them on the internet. You can do that here using the settings. Here you can add a new source, and here use a local folder. Okay. Okay, let me install the NuGet package. Okay. So here, as expected, we have an error. And if we try to build the solution, the build fails. And as I noted before, this is a difference between the two deployment options. The code fix provider is also deployed, and this allows me here to fix the code and use immutable array.create. Okay. We are not done yet. Let me show you why. So here, if I open the output folder, I can see here the DLL of the analyzer and also many DLLs that are dependencies of the analyzer. And these DLLs are not needed at runtime when this application is executed. They are needed only when we are working with the source code here for the analyzer and the code fix provider to work. So it would be better if the package didn't cause these DLLs to be put in the output folder of the consuming project here. Before showing you a fix, let me show you why this happens. So here's the NuGet package, and let me open it with a program called NuGet Package Explorer. You can use this program to inspect NuGet packages. And here on the right, it shows you the folder structure. And let me expand it here. So here we have the analyzer project DLL inside the analyzers.net CS folder, which is what we want to have, right? In order for the consuming project to pick up the analyzer. But then there's also another copy of the DLL inside lib and .NET Standard 2.0. And this is the part that causes the analyzer project DLL to be part of the output of the consuming project. So this is the part that we want to remove from the NuGet package. And here on the left, we see the dependencies of the NuGet package. And here we have a dependency on Microsoft.CodeAnalysis.C#.workspaces. And this dependency is what causing all the other DLLs to appear in the output folder of the consuming project. So one way to prevent these DLLs from appearing is to remove this dependency, right? Let me go back to the analyzer project now and edit the analyzer project file. Okay, so here I have added these two elements, and the first one is called include build output, which is set to false, and this will cause the build system not to include the analyzer DLL as an output in the NuGet package, which is this part, right? And this other element, which is suppress dependencies when packing, I set it to true here, and this will cause the build system not to include the dependencies of this project into the NuGet package. Okay, let me increment the package version here and rebuild. Okay, now let me go to the output and pick a new package and put it inside the local NuGet folder. Let me open this one now to see how it looks like. Okay, so it has no dependencies, right? And then there's only this analyzers folder. Okay. Now let me open the consuming project and then update the NuGet package. Okay, update to 1.1 and rebuild. Let me open the output folder. And as you can see, the analyzer project DLL does not exist here, and this is true also for the other dependencies. Okay. Again, we are still not done. Let me show you what happens when we try to consume the analyzer from a .NET Framework project. So here, when I try to install the analyzer into a .NET Framework project, I get an error which says the package does not contain any assembly references or content files that are compatible with that framework. So it seems this kind of project doesn't pick analyzers automatically from the analyzers folder inside the NuGet package. And based on the documentation, we need to include some PowerShell scripts that will cause the project to pick the analyzer. Let me show you. I'm going to go back to the analyzer project, and here I'm going to create a folder called tools, and inside it I'm going to create two PowerShell scripts, install and uninstall. Okay. Okay, so this reference from Microsoft describes many of the details I showed you so far. And from here we can get the scripts that we should put inside the install and the uninstall scripts. So here's the content for the install script. And here's the one for the uninstall script. And if we try to look inside these scripts, they basically look inside the analyzers folder, and they pick the analyzers inside this folder, and then they add it manually as an analyzer reference to the project. And here there's a section for language agnostic analyzers, and these are analyzers that work for Visual Basic and C#. And this code here does the same thing, but for analyzers specific to the language of the project. Okay. Now we should include these with the NuGet package, so that when the package is installed to the consuming project, the install script is run, and when the NuGet package is uninstalled, this script will run. Okay. Okay. So here I have updated the CS project of the analyzer to include these PowerShell scripts into the NuGet package. Let me now update the version of the package and build it. Okay. Let me now take the new package, copy it into the local NuGet folder, and then let's open the .NET Framework based consuming project. Okay. Okay, so let me open the namespace of the immutable array type here. And let's try to install the analyzer NuGet package now. Okay. So now we have the error here, and we also have the code fix, right? Okay, great. This concludes what I want to say about deployment options for Roslyn analyzers. Thank you for watching.